This rule can also be used to kind of explore other circumstances, because sometimes you're going to be asked questions along these lines. Can a triangle have sides with the given lengths, and to explain? So let's have a look at these circumstances. So the first one says, okay, can a triangle have sides with the given lengths of 6, 8, and 13? And so I have a GeoGebra slide here to look at. If I can pull it over. If it lets me pull it over. There we go. And I'll maximize that a bit. And as you can see here, I have 6, 8, and 13, and these sides are programmed to swivel, so I could actually put them in certain positions. And so, can I form a triangle out of these lengths? Well, as I see here, as I draw these a little closer and closer and closer, maybe this up a little bit, and this up a little bit, I can form a triangle. So yes, I can have a triangle of lengths 6, 8, and 13. On the other hand, when I look at the second scenario, can I have one with angle lengths 3, 9, and 12? As I try to manipulate this, no matter how I try to manipulate these together, I can't get these 2 points don't match up until actuality they're both along this line down here. Now that's not a triangle. That's a segment. So, these two sides, which total 12, and the third side being 12, shows me that, no, that's not going to be a triangle. And there's a rule that's centered around that. And that rule kind of goes along with the fact that when I do this, I look at the longest side, and I compare it to the sum of the other two sides. So, for instance, here, when I look at 6 plus 8, those are the two smaller sides. It adds up to be 14. As long as that's greater than the third side, then yes, this will work. Whereas when I look at the other circumstance, look at the larger side is 12. 3 and 9 are the shortest side. So when I do 3 and 9 and get 12, it should be greater than 12. So because of that, it was not a triangle, as we saw that in the previous picture. So two sides of a triangle are 7 inches and 9 inches. What is the range of possible lengths of the third side? So let's have a look at this circumstance here. I have another GeoGebra demonstration here. I have this side fixed to be 16 units long. And, if I look at this here, if there's 7 and 9, again, kind of like the circumstance here, then that would match up to be, a segment. And if it was bigger than 16, no matter what I do, these two points are never going to overlap and be an intersection point, so I would never be able to form a triangle. So it seems as though I have to have, this third segment over here be shorter than 16 for this to work. And if I come up with other measurements, I could probably rearrange these, until I get them to overlap, so I can form triangles and things like that. So what's the lower end is the question. How far down can I go? Well, if I shrink this down to, say, 2, try to get 2 exactly if I can. As close to 2 as I can. That's always the tricky part of this. That's close enough. As I try to do this, as you can see here, I'm not able to really form a triangle. As I keep trying to move this around, well, this one is a little bit over, so it still might have a small chance of working. Yeah, I could get a triangle there, but if I go a little bit shorter than 2, like say here, no matter what I do, these points are never going to match up. I mean, the closest I get is when they're along the same segment. And I even pull it down here, they don't quite match up. So as we see, the lower end of that is 2. So basically, with this situation, to kind of go over these, this circumstance, I was able to determine that there was an upper boundary when I just added the two lengths together. So the third side has to be less than the sum of the two. And then when I looked at the lower end, I basically just had to subtract the two and get the lower boundary. And these are values that they still cannot equal. So they have to be between these two values without actually equaling them. So I would say that the third side would have to be somewhere between 2 and 16 inches. And that's kind of what kind of goes centered around this rule here, the triangle inequality theorem, which says that the sum of two sides of a triangle is always greater than the third side. When it equals the third side, that's when we get a line segment. And if I get a circumstance where I add up two sides and it ends up being smaller than what the third side is, I just can't form a triangle. And those are circumstances like wherever, I would get like a third side that's either too small or too big to fit into this category. That's the end of this little mini lesson. If you have any questions, please feel free to contact me. Have a good day, everyone.